When viewing this video, it may be helpful from time to time to pause the video and to try to figure out the next step before I do it myself. Then you can resume the video and see how your step matches my work. So this topic is evaluating a logarithmic expression. If you recall from the previous topic, if we have an exponential equation, we can rewrite it as a logarithmic equation and vice versa. We will make use of that topic or that skill in evaluating these logarithmic expressions. So in this sample, in this example from Alex, we have log base 6 of 36 equals some value, and we're trying to figure out what that value is. Now, if you don't know how to do this, one helpful thing is to rewrite the logarithmic expression here as an exponential expression, or equation in this case. So the base is going to be the same, so it's going to be 6. We don't know what the power is, so it's 6 to some power equals 36. And so what we have to do is we have to determine what power of 6 is 36. And so that is 6 to the second power is 36. And so the answer is 2. Log base 6 of 36 equals 2. Another way of thinking about this is that what the logarithm does is it strips off this exponent here. So if the base is 36, what exponent gives you, if the base is 6, what exponent gives you 36? And that answer is 2. The exponent here is 2. So we can try a couple more problems. So let's say log base, so let's say 2 of 16 equals, and then we have to figure out what this value is. If you don't know, it's helpful to rewrite this as an exponential equation. So I don't know what this is. So I'm going to rewrite this as 2 to some power, I don't know what this power is, equals 16. And so now when I think about this, 2 to the first power is 2, to the second power is 4, to the third power is 8, to the fourth power is 16. So this is going to be 4. And so log base 2 of 16 is 4. Because this is the exponent, 2 to the fourth power equals 16. Now this gets a little bit trickier, a little bit maybe more confusing if you're dealing with fractional exponents or negative exponents, but we can still do that. So let's just take a look at a couple more. So let's say log base 5 of 1 equals what? And if I don't know what this is, I can always say, well, 5 to what power equals 1? And you maybe remember 5 to the 0 power equals 1. So this answer is 0. And in fact, that's going to be true of anytime you take a log. Doesn't matter what the base is. Log of 1 equals 0 because, so for any base, log base a for any base of 1 equals 0 because a to the 0 power equals 1 for any base a, as long as a is not equal to 0. So this is going to be true for all values of a. For it doesn't matter what the log is, or it doesn't matter what the base is, log of 1 equals 0. So we could take a look at maybe something with a negative exponent. So log base 3 of 1/9 equals, and so again, if this confuses you, if you can't quite figure out what this is, you can rewrite this as an exponential equation. 3 to what power equals 1/9. And you may at first think 3 to the second power is 1/9, but no, 3 to the second power is 9. Now, because this number is greater than 1 and this number is less than 1, there's some sort of reciprocal going on here. And so this is going to be a negative exponent in order to get that reciprocal. So the reciprocal gives you 1 over something, and then it's the second power that will get you the 9. So this is going to be 3 to the negative second power. 3 to the negative second power is 1/9, and so this is negative 2. The same thing can be true of fractional exponents. So let's take a look at one of those. So log base 4 of 2 equals what? And again, that means 4 to some power, I don't know this power, equals 2. And again, we may be thinking, well, 2 squared is 4, so this is 2, so this would be the second power, but 4 to the second power is not 2. So we have to figure out what this is. It's not going to be 2. Well, because 4 is greater than 2, and it's not reciprocal, so this is not going to be a negative thing, but because 4 is greater than 2, I'm probably going to be thinking about some sort of rational, some sort of fraction, some sort of root or radical. And it occurs to me that the square root of 4 is 2. So the square root of 4 is 2. Well, that is 4 to the 1/2 power is 2. And so this gives me 1/2, and so the log is going to be 1/2. So these are not that difficult if you rewrite them as exponential equations. And it may take a little practice, but if you get stuck, if you get confused, there's two ways of thinking about this. One is it will strip off the exponent. So if you can figure out what that exponent is, all you have to do is write the exponent down. And if that doesn't help, take the time to rewrite this as an exponential equation, and then you can figure out what exponent it's going to be.